Okay, so here's a graph you should be familiar with, the graph of y equals x squared. So what if we wanted to draw a graph of y equals x squared plus 2? All our y coordinates are now going to increase by 2. So when x equals 1 here for y equals x squared, y also equals 1. But for y equals x squared plus 2, y would equal 3 at that point. And similarly, when x equals minus 1, y would equal 3. And when x equals 0, y would equal 2. So we can see just from plotting these few points that what's going to happen to this graph is it's going to shift upwards by 2 units. So let's have a look at a few more examples. Okay, so say I wanted to plot the graph of y equals x plus 2 in brackets squared. Let's just think of a few points. When x is equal to minus 1, y is going to be minus 1 plus 2, which is 1 squared, which is also 1. When x is equal to minus 2, y is going to be minus 2 plus 2, which is 0 squared, which is 0. And when x is equal to minus 3, y is going to be minus 3 plus 2, which is minus 1 squared, which gives us 1. So we can see just from plotting these points, we can join them together in our quadratic shape, and we can see what's actually happened to this graph is it's translated to the left by 2 units. Okay, so now we're going to sketch the graph of y equals minus x squared, and let's look at a few points for this. When x is equal to 1, y is going to be equal to minus 1 squared. Now remember your rules of BODMAS. You're going to do the squared bit first. We're going to do this first. So 1 squared gives us 1, and then y is going to be equal to negative 1. So we can plot that there. When x is equal to 0, y is going to be equal to minus 0 squared, which of course is 0. And when x is equal to negative 1, y is going to be negative 1 squared. Negative 1 squared is 1, so y is going to be negative 1. So we've got a few points. We can join them up in our quadratic shape. And there we've got the graph of y equals minus x squared. And we can see that that is our original graph, y equals x squared, reflected in the x-axis, the line y equals 0. So let's look at one more example. So we want to sketch the graph of y equals 2x in brackets all squared. Again, let's plot a few points here. When x equals 1, y is going to be 2 squared, which is 4. When x equals 0, y is going to be 2 times 0 squared, which is 0. And when x is negative 1, y is going to be minus 2 squared, which is 4. So if we join these together, our quadratic shape, we can see that it looks like our quadratic has been stretched. It looks like it's been pulled up parallel to the y-axis and stretched, so it gets steeper a lot quicker than our original function y equals x squared. Now what we've looked at are 4 of the transformations of graphs. We started off with a simple graph, y equals x squared, and we've done things like made it negative or multiplied our value of x inside here rather than outside, and we've seen how that's changed the graph. Now it turns out there's general rules for transformations of functions. If you think you can figure them out from watching this video, fill in the table, but if not, we will be doing that in the lesson.